Hello everyone. In this content today we are trying to understand about the joints. So this content is being adapted from earthengine guides, and in the earthengine we have these joints, very much important function there. So this joint is used to combine elements from different collections. So this can be image collection, and it also can be the feature collection. So the main objective is to find the properties of a collection and to find the similar properties of the other collection. So we will be merging the two different collections based on those properties. So that is the main objective. So the condition is specified by the EE dot filter. We have the left field, which relates to the specific property of the primary collection, and then we have the right field, which specifies the property of the secondary collection. And the relation can be one-to-many, or it can be one-to-one, so depending on the collections. We can also set how many matches we need to bridge off. So after doing all those or specifying the specific joining function, we have this join.apply, and this does the output of the join. So what I've done is I have copied all the codes from the earthengine guides, and we will briefly try to see the codes, what each code does or what each join does. So we have the very first one. This is called the simple join, and this simple join, what it does is it just filters from the both of the collection and finds the things that are common to both of those elements. So I've already done this, and I've got something here in the console. So here at the very first we have this collection, so bounded by some by this point, and we have some dates here: April, May, June and July. Then we are filtering this collection based on these two months, April and June. And then we have this secondary collection, just there are two different variables. So the second one here has been filtered with May and July. And after that we have this equal filter. So this is being done by EE.filter.equals, and inside which we have this left field and the right field. So as mentioned earlier, left field is related to the primary collection, and right field is for the secondary collection. So we are specifying the time index or the system index for both of those collections. And here we have this EE.join.simple. So this is our joining function being assigned to this variable simple join. And what we do is we just have this variable simple join. It contains that function, and this is followed by .apply, and then we have this primary and then secondary and our filter. And after printing this, what we are getting is, so I have already done this. So the main result of this simple join is to retain the common elements among the two different collections. So what we're getting is only the images from the month of May. And why is this? Because the May is common to both of those collections. So that is the main function. That is the what this simple join does, to find the common elements from both of the collections. Then we have the second one. So this is the inverted join, and what it does is it gets all the images in the primary collections that are not in the secondary collection. So previously we saw in the simple join we had only the result of the month of May, which was common to both of the collections. But in this inverted join we get the month here, that is April, because the April is only present in the primary collection, and all the things are same except we have this ee.join.inverted. So this is the function being used here, and all other things are same, and we have this result. This includes the images only from April, which is present only in the primary collection. So this is the inverted join. Then we have the inner join, very different compared to the previous two. So what it does is it tries to find the common between the two different feature collections and kind of merge it into the new one. So for example, the very first one here, we have this primary feature collection. So these are the empty features, so only with the two different properties. So we have this FOO property, and then each has been labeled. Similarly, we have this secondary feature variable, which contains the other set of feature collection with the property as bar with some values in it, and then there is level. And after that, here we have this ee.filter.equals. So our left field, which is the primary one, contains the FOO, and the right field contains the BAR. So this is to be matched between the two. And then we have this ee.join.inner, and then we have this primary and secondary. So we are trying to join both of those feature collection, and then we're applying this to the by dot apply here, and we have these two different collections, and then we have our filter here. So if we run this, what we are getting is, so we can see the feature collection here, and if we see the features, so we have got the 4 features from this join, and if we see the first one here in the properties, so what we can see is we have got this 1B FOO level. We're selecting 1B, and then we have the secondary one. So we are merging two different of course we are merging two different feature collections, so we are getting 1B and 1E. So we can see each of those. So basically what it does, it is kind of finding the common one, this one and this one, making it new one. Similarly, this is 1B and 1E, and there is 1B with 1F. So these are it is kind of making a combination based on the first property. So anything that is common will be retained or will be made as the new feature here. So these are the possible combinations based on the first property. So if we see the text as I have copied from the earthengine guides, so it says the output represents the match. So where the matching elements, they are stored in two properties of the feature, and both of the properties are retained and made as available as the property. So this has the importance in some cases, and the earthengine guides shares the example the very important one. This can also be applied to, I think, the Sentinel-2 as well, because Sentinel-2 has the two different data set. One of contains the images and the other contains the cloud masking data set. So there are two different data sets. Similarly, in the earthengine guides, we have this example within this inner join. So what is here is that the MODIS is one image collection, and there is also this next one, which is the MODIS quality data. So these are stored in the separate collections, and from the image data and from that quality data, so we need to merge those two different data sets. So this has been done here. So let's see. So we have this data filter, and we have this image collection, and then we also have this MODIS collection quality data set. This is also being filtered, and here we have this ee.join.inner, and then we are doing this ee.filter.equals, and then we have this sets of properties that's the time start property, and then we have this mixing of those or merging of those two different collections based on the properties. So we have this inner join.apply. The first one here is the MODIS dataset, and the second one is the quality dataset, and then this filter here. So this gives us something like this here. So we have these features, and we can probably see what it contains. So now we have this primary one and the secondary one. So two different images has been merged. So it is just making a multiple combination based on those time properties. And then the final one here is the continuation of those previous codes by concatenating or grouping of those properties. So here we have this .cat, ee.image.cat. It just merges two different properties. And we can see the final one here. This is the final one. So now we can see that here we have this image. So we can see two different collections being merged. Previously there was only one image, bands one here, and then we had this two different bands in different properties. But after this ee.image.cat, the final one, we get the two different collections, which now has all the bands within the single image. So this is what the inner join is doing. Basically, it is trying to find the combinations based on the properties assigned. Then we have this Spatial join, and the Spatial join matches the secondary collection. It says the matches from the secondary collection as a named property of the features in the primary collection. So basically, the objective of the Spatial join is to find the images of a collection based on something of the other collection. So for instance, this example shows that we can find the MODIS imagery. So we are finding the MODIS imagery acquired within the 2 days of each Landsat image. So the time property will be of Landsat image, and within those time frames we want to find the MODIS images, acquired MODIS images. So we can run this. So we can see here this primary collection is the Lancet one. We have filter dates, filter bounds. Then we have this Modis image collection. We're filtering the dates. And here we have this 2 days converted into the milliseconds. So just the change of the unit. And after that we have this time filter, ee.filter.or, ee.filter.maximum difference. So this is the assigning of the time filter to define the images to be filtered within those time frames. And then we have this ee.join.sepal. So some matches key has been provided, and then here some time properties is being provided, and then we have this sepal join. Then we're applying this by dot apply, and then we have this primary and secondary collections, and then followed by the filter. And if we run this and see the features, so at first we can only see the Lancet images, but if we see the properties at the very end, so at the very end there is something called the Terra. So this contains the Modis images. And maybe there are methods, some other methods to find or to bring this like previously what we saw in the previous join. We can bring this images, combine those images and bring within this Lancet image. So the objective or the main task of this sepal join was to find those images based on the time frame of the other collections. So that was what sepal join was doing. Similarly, we have this sep-based join. So this says that this is equivalent to the sepal join, except for each element in the primary collection, it septs the element from the secondary collection. So we can run this and see. So to be honest, I am not exactly sure, because it says that it septs the elements from the secondary collection, but what we're getting is the images of the primary collection. So I'm not sure for this now, so I still need to understand more of this thing. But basically it's what it says is if it wants to find those images of this meteorological data based on this primary collection. So, but I'm still not sure. I still need to learn this. But this sep-based join and this sepal join does the similar thing to find the images based on the other time frame of the other image collection. Then we have this sep-first join. So this says that sep-first join is somewhat equivalent to the sepal join, except this does for the secondary collection. It septs the first element from the secondary collection. The earthengine guides don't share the example here, so I haven't done anything, just the text. And finally we have this important one that works with the geographical or the spatial locations. So the spatial join is to merge the two collections based on the geographical information within those collections. So there is an example. It says that to find the power plants within the 100 kilometers of Yosemite National Park, USA. And here we can see the primary collection. So this is our national park here. This is the primary collection. Then we have this power plants data set, and here we have this dist filter, and then we have this ee.filter. Within the stance we provide the distance. Then we have this left field and right field, so the filter is being done for the spatial locations or the geographical locations. And then it says we match the key and the major key, so the points and the distance are something here provided, and the Spatial join. Then we have this join provided, and then primary and secondary collection and our filters. So if this is printed, when this is printed, it gives us something here. So this is just doing some kind of GIS operation, and this gives us some feature, and there are some things here on the features. So basically we are getting some common things within those 100 kilometers of the park. And there is also the next example. So this example tries to print the chart, and so we can see here what it does. It tries to count those power plants within the 100 kilometer of the feature. So the first collection will be the polygons that represents the US states, and there is also the secondary collections which contains the point locations representing the power plants. And the objective is to find the number of intersecting number of power plants being intersected within those states. And we can see here, so the first one is the primary collection, second one is the secondary collection here, this is power plants, and then we have this spatial filter and left field and right field, both specifying the .geo, that means the geographical data to be used. And then we have this ee.join.savall, some matches key has been provided, important one here. And then we are using this Spatial join and applying this dot apply, and then here we have this function, and in that result we're applying this function here, and it gets all those power plants as the list, and it kind of counts by dot size, and it sets the property as the end power plants, just the naming of the naming of those. And after that, here we have ui.chart.feature by feature. So this is the function for doing the graphs. There are many different types of print chart functions. So this is one of that. And then we have this collection, this resulted feature collection, and some other parameters to print the chart. So the result is something like this. So basically the last one here is directly related to the GIS operations. And to summarize, I want to summarize this thing. So again, just the objective of this join is to merge two different feature collection or two different image collection. So the condition is a specified ee.filter. So we can see that ee.filter is being followed by different types of filter. So we can really play with this. And then we have this idea of left field and right field. So left field will have some property in the primary collection, and right field will have some property of the secondary collection. And based on that, we also provide the join. Finally, we provide the join, and then after that, we do the output of the join by dot apply. So that is the main objective here. So I hope this was helpful. I tried to explain the things. So if this was helpful, thank you for watching this.